Hello and welcome to my chemistry assignment presentation. My chemical reaction revolves around the Benedict experiment of copper hydroxide with glucose. Let's first begin with copper hydroxide. Copper hydroxide is made up of three elements, copper, oxygen, and hydrogen, and five atoms, four evenly being hydrogen and oxygen, and one being copper. When the three are chemically combined, we obtain a balanced equation of copper oxide, or cupric oxide, and H2O. Cupric oxide has one copper and one oxygen, whilst H2O has two hydrogens and one oxygen. And as we know, together they form copper hydroxide. But let's talk deeper about its structure and process. Let's circle back to the beginning. When the three elements are heated together, copper becomes known as copper II or cupric oxide, which means that it loses two electrons in a process called oxidation. Oxidation is caused when an atom is heated and when left to cool will decrease the amount of electrons. Overall, when the atoms of the copper and any element is heated, its electrons become excited to higher energy levels, and when left for their energy to drop, it causes the substance to emit a quantum of energy, or in other words, a physical change. Now, if copper is reddish-brown and hydroxide is colorless, how is the product blue? Well, you guessed it. Oxidation changes the color of light, and can be justified here. Copper hydroxide is a double replacement reaction, meaning its initial elements only change in its relationship of bonds. In this structure, we see that first the molecules of water H2O break apart and its oxygen mocks or evens out the other oxygen in cupric oxide. From this, the two hydrogens do the same. This is a balanced structure. Now let's move on to the other half of adding glucose to copper hydroxide. Glucose is composed of carbon, hydrogen, and oxygen. With 6 carbons, 12 hydrogens, and 6 oxygens, there is a total of 24 atoms. Now, when applying the glucose and heating the copper hydroxide with it, we repeat the same process of oxidation. This means that cupric oxide becomes cuprous oxide with a loss of only one electron, and if we look back at this table, we see that cuprous oxide is red and even sometimes yellow. The copper hydroxide obtains a molecular oxygen which is in its formula. Molecular oxygen is when two oxygen atoms are held together by a covalent bond showing as O2. Now when glucose reacts with molecular oxygen, it loses electrons and goes through what is called oxidation. However, in the presence of oxygen and glucose, it's more formally a process of respiration, in which reduces the glucose or breaks it down further by releasing its energy. In more simpler terms, copper hydroxide reverses the action of photosynthesis, known as respiration or photorespiration, in which oxidation of carbon takes place. Carbon is a vital link to glucose and has been separated in this experiment, whilst copper, in this case, acts as more of an appearance effect in the experiment. When glucose reacts with copper hydroxide, after all the oxidation and respiration, we get cuprous oxide. Therefore, this experiment, called the Benedict reaction, fulfills its purpose of breaking down glucose, thus reducing glucose through oxidation and respiration, with copper hydroxide acting as a base/fungicide for glucose.